Good afternoon. My name is Alejandro Bagwandine, and this is my final presentation for Milestone 5 in my Modeling and Simulation course. Over the semester, I designed, implemented, and analyzed a scholastic SIR infectious disease simulation in Java. Today, I will walk through the model, the scenarios I created, the results I observed, and what I've learned. My simulation is based off of the classic SIR model. The population is divided into three different sections: susceptible, infected, and recovered individuals. Each step, infected individuals make random contacts. Infections occur with probability beta, and recovery occurs with probability gamma. This produces a realistic epidemic curve and allows us to test intervention strategies to see how they change the outcome. So here we have my simulation, my populations, and my persons. As you can see, my simulation is fully implemented in Java. Each person in the model is represented as an object with a health state and internal timer. The population class manages all the individuals, and the simulation class handles all the infection, recoveries, contacts, and the metric collections. So we're going to go ahead and do a quick pass through of each of these in the simulation. Now, I've also created a metric collector that records my SIR counts at every step and automatically saves them into CSV files. This will allow me to run multiple scenarios and analyze them statistically. So here is my metrics, and then it will save them into these baseline, which allows me to keep my information organized. Alright, so here's an example of my simulation running. We're going to go to main and run the Java. As the model progresses, it prints the numbers of susceptible, infected, and recovered individuals at each step. This allows them to visually confirm the epidemic curve and confirm the dynamic behaviors realistically. Alright, so starting at my baseline within standard initializations for the baseline scenario, and it has my steps: suscepted, infected, and recovered. At the end, my recovered should be at 50 people. I implemented three intervention strategies with an addition to the baseline. I have my vaccination 30 or vaccine 30, which is 30% of the individuals start as recovered at the time 0. So 30% of infected are recovered. And we have quarantine 50. Once infection exceeds 5%, contact per infected person are reduced by 50%. And a combination of both is as well researched. Alright, so those are both recovered. Alright. Here is the epidemic curve for the 4 scenarios. The blue is the baseline, and it has the highest peak infection level. Vaccination at the time 0 lowers the peak noticeably. Quarantine flattens the curve by reducing the contact rates, which grows. The combined strategies produce the best outcome: a lower delayed peak and a faster outbreak solution. We also have the peak infections and the time to peak per run. In summary, this project has helped me understand scholastic modeling, intervention designs, simulation architecture, and statistic validation. My code base is fully documented in GitHub, including all documents, datasets, plots, and LaTeX reports. Thank you for watching my presentation.